Hello everyone, this is the BMO Dev channel. I am Breno Medeiros and I want to show you guys how to use Google's MLKit in Objective-C for document reading in iOS. So, Google used to have this engine in its own Firebase cloud services. But now, Google separated this into different things. What uses cloud computing, like storage or anything that runs on cloud, will be configured in Firebase. But anything that will run on your own devices and don't require anything from Google will be run locally and won't need to pay anything. Like this. This is its own recognized text engine. And that's why I'm recording this video. Some of you may have saw the previous video I did to the VisionKit framework from Apple, and it does just the same thing. If you don't, you can check it out here in the rectangle I'm stacking for you, but it's not a pre-required for this video. You don't need to watch this because it's another library, another API, another framework. It's completely splitted from this. Now, the reason I'm doing this tutorial to do the same thing is because each of them has its own advantages and its own problems. For example, Apple's framework VisionKit has a good thing that it don't increase your app size because the VisionKit framework it's on every iOS device from the iOS 13 or later. But at the same time, it has a bad thing that you need a high iOS version for this, at least 13. And this is a problem for a lot of apps that wanna have its own app on the most kind of devices out there. But the MLKit from Google has the advantage that it works on a lower version of iOS, at least 11, but it has a problem that increases a lot your app size because Google needs to put their own engine inside your app because it not comes with the iOS. So for a demonstration, this is how your app will look like. You can tap on scan and it will show here a card with the detection. Gallery 1, please enter. That is the text from this image. And you can put here on the text field so the user can copy that or whatever. And we know every corner of the rectangles from the line of the text and the words. Now, let's do it. Let's start a new Xcode project. Open up Xcode and tap on Create a new Xcode project. Select iOS app, hit Next. And now, for the name, I'm gonna put BMO MLKit recognition. Let's storyboard, UIKit app delegate, Objective-C. Hit Next. Choose the folder you want. I'm gonna doing desktop, YouTube. This is my third video, and I like to create a Git repository, but you do whatever you want here. Don't add in a project, workspace, yeah, group, no group. Okay, let's hit create, wait for it, and here we go. Now, let's create a new group and name the folder resource. Show in Finder, open the folder, put the image that you want to recognize. I'm gonna put this gallery one, please enter, but you can choose any other one. And here it is. Just drag and drop to the resource folder. Let copy files if needed. Hit finish. It won't duplicate because you already copied here. Now let's go. Just run once to see that everything's alright. Yeah, everything's fine. So let's stop it. Let's go here, hit show in Finder, hit here in your name folder, open a new terminal in this folder. Okay. Now you can do and pod in it because we need Cocoa pods to put some dependence here. Let's see the folder of the project again. And run pod init. It should create our pod file so we can run our dependencies. Yeah, it did. Open the pod file in the text editor you want and write our dependency. Pod Google MLKit text recognition. Save it, close it, and do pod install. And yeah, it's done. Now close the terminal. Now you will open the project with this white paper project that's named Xcode workspace. Open it up. And here it is. Now let's create our UI. Go to main storyboard. hide this, open another view with Ctrl Command T, hit viewController.m, hide that, and then let's put our components. Do Command Shift L to open library. Search for text view. Drag it until almost the half. And then drag with Ctrl pressed from the text to the view and set equal height. Now open the right side, go to the inspector of sizes, hit the height. Here on proportional height to superview, hit edit, and the multiplier you should do 0.5. And now to this component, do Command Shift UI, and then click here, like 20, 0, 20, and then press enter. Hide it again. And now let's put an image view. Image view. Drag and drop. Drag it here. Okay, let's put our button. You can call it whatever you want. I think I'm gonna call it scan. Scan. Document. And now let's add our constraints. Twenty, 10, 20, and our height. Hit add 4 constraints into the image. Hit constraints, add 10, 10, 20, 20, and hit add 4 constraints. Okay, we are almost done. And now let's open again our library activity indicator view. Let's make it a little bit larger. Right here in the middle, hit inspector, and now add constraints. Horizontally in container, vertically in container. Add two constraints. And now change the style to larger and the behavior. Hit animating, disable user interaction labeled, and that's it. Now hit Command S in your keyboard so we can save it. In this text, clear it and write resulting text goes here. Okay. Now let's make our connections. Here in viewcontroller.m, in the interface, with the Control key pressed, drag and drop the text here and write, let's see, result text. Hide the right, hide the left. Okay, hit enter, hold the Control key, drag and drop the activator indicator, and now name it, I think, activity indicator. Yeah, to the connection. Now hold the Control key, drag and drop your image, and call it image view, and hit connect. And our last component, hold the Control key, drag and drop scan document, drag it here in the implementation tab, and we will call it, let's see, scan document. Hit connect. Yeah. Now we are done. Let's run. Oh my. I made a little bit case error. Let's do a refactor here. Rename it. Wait a little. Now let's lowercase it here. Hit enter. Hi. Now the refactoring is done. Let's choose our iPhone 12 mini simulator. Now hit run. Strange. Nothing appear here. All right, here it is. Our image that I didn't specify it. Our indicator from activities, our text field, our button. Yeah, everything's here. Now let's stop the execution and start writing our code. Close this, hide that, and then show the left side. And let's continue on our viewController.m. Now let's fix some things that we didn't want to. Here in view.didLoad. First, let's go for our result text dot input view to receive and UI view unlock init with frame cg rect 0. This will prevent the keyboard from showing when we hit on the text field. Don't open keyboard when hit text field. Now let's fix another thing, our activity indicator. It won't appear only because the view has loaded. So activity indicator, stop animating. Stop animation. And then for drawing our words where it was detected, we are gonna need an annotation overlay view. It's just a view over our image view. So let's create an annotation overlay view and instantiate our image view. Start by image view dot image receives the UI image with the image named image has text. Has text. All right, and now let's create our annotation overlay view. Oops, I didn't instantiated it here. This will be our property non-atomic UI view with the name annotation overlay view. will be our view to draw the recognized texts. And then let's create an NS mutable string so we can increase the words that we are detecting. I think I'm gonna name it result text instead of this. So let's change this name and do a refactor rename. I think the name, I will call it just a simple text fill. In here, increasing string to recognized words. It will be a property, non-atomic, NS mutable, no array, no string. Named result text. Yeah. Now we can make the call from annotation overlay field. It will receive the instantiation of UI view alloc init with frame cg rect 0. And now let's make some constraints here. Annotation overlay view dot translate out resizing mask into constraint will be no, and annotation overlay view dot clips to bounds yes. Now our image view will add this subview, name it annotation overlay view. And our NS layout constraint function named activate constraint will receive an array of annotation overlay view dot top anchor, the leading anchor, the trailing anchor, and the bottom anchor. Constraint equal to top anchor. Will be the image view dot top anchor. Now let's copy that paste it 4 times, and then let's change it to leading anchor, and here lead anchor. The same for the trailing anchor, the bottom anchor, why is this error appearing? Oh, it's an array, so that's more like it. Now let's run to see that everything's fixed. Building, running, and launching. Wait for it. Yeah, it's not animated. The keyboard don't show, but for some reason the image view don't show the image. I know why. I forgot to say that the activity indicator is hiding. Yes. And I forgot to put our image in our assets catalog. So let's drag it here. Hit Command S to save. And now let's run it again. Here it is. Now that our UX is and UI is all completed, let's write our text recognition code. Stop the execution, and then let's write our code. Everything starts from a button, right? So let's write here what will remove the detection annotation from the annotation overlay view. Let's write a for statement that we will start with a UI view named annotation view. It will be in the annotation overlay view dot subviews. In every single of them, we will call the annotation view methods call remove superview. This should clean it, and our self dot result text will be a new NS mutable string. New. And then let's clean the text from the text field. Self dot up dot slash text field dot text will receive an empty string. Now it's done. But let's clean this in a separated part of the code. Let's create a method for that. It will be called it will return void, and it's gonna be clear results. And here we will call it self clear results. Done. So before doing that, I think I'm gonna make the activate indicator start. So active indicator start animating, and activator indicator will be no longer hiding. Now let's call our image detection text. Self detect text on device in image, calling the image view dot image. And now let's create this method. It will return void, and with the name detect text on device in image, and we will receive the UI image. Named locally image. Now the error is gone, and let's just check if the image exists. So if statement, check if there is no image. If there's no image, just return. But else, let's start our text recognition. It will be MLKit text recognize. Oh, I forgot to do the imports. Go to the top, do the import header named UI utilities. It's a class that we're gonna create it right now. With hit on your folder, click on new file, new Cocoa Touch class, hit next, UI utilities that we are importing, hit next, hit create. Wait just a minute. Now it's created. To do our rectangles in the image, we're going to import in the header file our AV foundation and avfoundation.h. And we're going to import our UI kit and uikit.h. As soon as our Google's MLKit. Oops, import MLKit. And here inside, let's create our public method that return void named add rectangle to the image. And this rectangle will be in cgrect named rectangle to the view of kind UI view named just view with the color UI color named just color. Now save it, and in the .m file we're gonna write some attributes that's gonna be static cg float const rectangle view alpha with 0.3 and static cg float const rectangle view corner radius with the value 10.0. Okay. Let's do an ns assume no new begin, and here after the end and no new end. Now we can write our implementation. Do a plus void, the same thing we did in the header file. Let's copy here and paste there. Open the method and let's write an local UI view named rectangle view that will be unlocked. So UI view unlock and initialize with frame of the rectangle that we passed. And now for our rectangle view, let's take our layer, and from that let's take our corner radius to the rectangle view corner radius. And let's set our alpha value to the rectangle view alpha. And finally, our rectangle view dot background color will be the color that we received. And finally, our view that has the method addSubview will pass the rectangle view that we created. Now, our method is done. Our UI utilities class is done. And ETORS has the MLKit entire API from Google here. So if we import the UI utilities.h, we are also importing the MLKit API. So let's get back to the view controller and then fix this by putting the .h here. Now this should be already recognized. And here it is. So let's create our variable named onDevice text recognizer that will be initialized. MLKit dot text recognizer has the method text recognizer. Now let's initialize our vision image object with the given UI image. So let's write MLKit vision image. We receive the vision image variable and will be allocated. MLKit vision image alloc and will be initialized with the image. And then our new vision image dot orientation will receive the image dot image orientation. And now that we have an image made for the MLKit, let's make the calls for the results by hitting self.result text will be appending string of the declaration running on device text recognition dot 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 and enter. And now let's call a method that will do the processing. But first, let's create it. It will be a method that return void and do the process that receives an MLKit vision image named vision image with text recognizer. MLKit recognizer, text recognizer. And let's open it. Oops, I forgot to name it. I'm gonna name it just a text recognizer. Text recognizer. Alright. Now we can make this call. Process. Self process. The vision image with text recognizer on device text recognizer and close it. The error should be gone, and it did. Now let's write our scope. It's gonna be our biggest method here because it will do all the process we need. So let's write a weak relation with the type of self that will be weak self that receives the self. And now let's will, not will, weak. All right. And then this will be our start recognize text. Now, just call the text recognizer that has the process image named vision image with the completion of MLKit text, nullable text, and as error. And inside of here, we will do our code. And down here, will be the end of our text recognition. Now, when it's already completed, what we're going to do is stop and hide the indicator of the activity. So let's call self arrow activity indicator, stop animating, and self arrow activity indicator hiding yes. And now let's just create a strong variable with the type of week self, that is a strong self, and receive the weak self. Having that done, something's wrong here. Let's see. Strong type, no, type of double E. Now, and then let's check if our text is new. If it is, we don't have anything to do here. So let's start and exclude. And here and exclude. So let's do a strong self dot resulting text, and our ns mutable string, that is a string with format. Text, recognizer, failed, with error, and the name of the error. Percentual is and will be filled by the error. Error dot localized description with the detect detection no result message. Use of undeclared identification detect no result message. What did I do wrong? Yes, right. I forgot to create this message. So over here, up and above the view controller, let's create a static ns string of a constant named detection. Let's copy here, paste it there, and it will receive the null results returned. Here we are. Let's make our strong self show our results. And we need to create this method. So here, let's write an returning void method named show result. Not show the result, show result. And then it's gonna be an UI alert controller named results alert controller that will receive an UI alert controller alert controller with title. The title will be detection results. The message will be new, and the preferred style will be an UI alert controller styled action sheet. Okay, and now our results alert controller will add the action of an UI alert action that do the action with title. With title. Named. Okay. And the style will be an UI alert controller style. Destructive and the handle will be in result arch controller dot not dot and dismiss view controller animated yes, completion no, and it's done. Now let's make our result alert controller dot pop over presentation controller dot source view will receive the self dot view. And now our result alert controller dot pop over presentation controller dot source view will receive the self dot view. Oh no, I should just do the message receive the resulting results text. Why it's not showing results text? It's right here. Oh, I forgot to put the dot here. Let's do a command B to build. And spawn. Now let's go to another line, do the self presentation view controller no present view controller let's create this method present view controller that will receive the results art controller animated will be yes and completion will be new and that's done. Now just to make it developable, let's create a log that will print the value of our results text. And now let's get back to our process. Here we're trading our Xcode. And now that's already shown. We'll do a return. And let's talk now about the case that we haven't text recognized. And the text to the text field, so user can see the copy and copy the result. We're going to show it on the text field. So let's do a self arrow underline text view dot text. We receive the text dot text. Now our text field is filled with the result of the processor. And now we're gonna do the showing over image. Text recognized by drawing. And now let's do a for loop. It will start with the MLKit text block with a single variable named block. In text dot blocks cg rect named it transformated rect. We receive the cg rect, apply a fine transform, and we receive the block dot frame and pass the strong self that we created, calling the transform matrix. Oops. Block.frame and strong self transformation matrix transform interface for view controlling the text declares this select. Alright, we didn't create this method yet, so let's go for it. Here, let's create an method that return ncg affine transform, and the name will be transform matrix. Let's open it, instantiate an UI image, name it just image, that will receive our image view dot image. And let's check if we don't have an image. Then we'll just return ncg find transform make with a lot of zeros. But else, if we do have an image, let's do our cg float image view width that receive the image view dot frame dot size dot width. Let's copy and paste here, change it to height. Let's create another cg float, name it image width for the image, size width, and the image height. Now let's create another cg float, name it image view aspect ratio aspect ratio that receive the image view width divided by the image view height. And now let's create our scale. CG float again. Our scale will be the image view aspect ratio in case it will be over the image aspect ratio. Then to the image view height divided by the image height. Else to the image view width divided by the image width. And then, now that we have the scale that we want, let's get the CG float scaled image width that receives the image width multiplied by our scale. And the same thing for the height. Now, let's take our CG float x value that will be the image view width subtracted by the scaled image width. All of this divided by 2. And the CG value for the height the same way. Oops, some mistake here. Alright, fix it. Now let's calculate our transform matrix result. It will be the CG affine transform, and the transform will be the CG a transform translate. Here we get the CGA TI for identity. The X value and the height value. Now let's do our return CG refine transformation scale that receives the transform and the scale twice. And we are done. I forgot here. Write the double points here. Okay. Now that we have our transform matrix method, let's finish writing the last method for our app. And now, in the for statement, hit enter and write UI utilities, call our addRectangle method that we created. It will do a transformates rect, transformed rect, transformed to the view self dot annotation overlay view, and the color will be in UI color purple. Let's make it readable. Okay. Now we have our transformed rect. Here we are running by blocks. And now we're gonna run by lines. Let's reply the for statement. And change the name block to line. It will be a line. And from the actual block, we call our lines. For the first line, let's create an CG rect. That will be a transformed rect, receiving the CG rect, apply a fine transform with the line dot frame, and again our strong self transforming matrix. And then our UI utilities. We'll call again our add rectangle transformed rect to view stronger self dot notation overlay view, and with the color UI color dot orange. And now let's run by element or word. Let's reply our for statement and right here do the CG rect, receiving the transformed rect, receiving the CG rect, applying a fine transformation of the elements. Oops, not line, element, element, elements. And elements dot frame. And here we have a strong self transform matrix. Now we need to do the utilities, UI utilities, add rectangle, the transformed rect to the view, strong self dot annotation, overlay, and the color will be an UI color dot green color. And then UI label, we receive the allocation of label, alloc init with frame of the transformed rect. Then the label dot text, we receive the element dot text. So the label dot adjusts font size fit width will be yes, and the strong self annotation overlay view will add the subview label. And the strong self dot results text will be append format, the string that will be some content, and a breakline, and the content will be the text dot text. And finally, our strong self will show our result. And of recognition. Let's run our project. See that, and if everything works properly, wait for it to launch. And here it is. Now let's hit our scan document. And there it is, guys. Here it is, gallery 1, please enter. Let's hit OK. It's labeling everything here, the elements, the lines, everything. And you can copy the content if you want, and the keyboard is not showing. When you see the hitting of the button, you will see for an instant that the text field is clear as the image too. That's it, guys. Hit the subscribe button to get more content like that, and see you next time. Peace.